years, drones functioned as remote-controlled cameras. They required a human pilot for every maneuver, unable to perceive or navigate without constant manual input. Even when early automation allowed them to fly pre-programmed routes, they lacked a localized brain. To recognize an object or avoid a sudden obstacle, the drone had to compress its video feed, beam it across a network to a distant cloud server, wait for a computer miles away to process the data, and then wait for a command to come back. That round trip takes time. In a high-speed industrial inspection or a hostile combat zone, a lag of even a few milliseconds causes failure. A delayed signal means a missed target or a violent crash. By tethering these machines to remote servers, we built aircraft that could cross physical distances in seconds, but remained dangerously slow to react. To make drones truly autonomous, engineers had to sever that connection entirely. The solution was a hardware breakthrough known as Edge AI. Instead of relying on distant servers for heavy lifting, cloud computational power is shrunk and embedded directly inside the device. Hardware like the NVIDIA Jetson Orin platform acts as a localized brain, running deep learning models right on the chassis, processing high-resolution video instantly. The aircraft operates as a flying perception system. It can track moving targets, map terrain in 3D, and alter its own flight path without human input or a Wi-Fi connection. The drone evolved into an autonomous, thinking machine the moment engineers severed its connection to the cloud. Edge AI is redefining modern infrastructure management by taking over jobs where the human cost is highest. Instead of sending people to climb wind turbines in bad weather, operators deploy autonomous scouts. Using computer vision models, the drone scans massive industrial blades, automatically detecting structural damage, corrosion, or microfractures as it flies. This removes people from dangerous, elevated environments. At the same time, the machine gathers consistent, high-fidelity data that a human inspector might miss. Localized AI has shifted the drone from a passive observation tool to an active participant in industrial maintenance, performing high-risk labor that once required specialized human crews. That same onboard intelligence allows these systems to handle environments that are vast and unpredictable, like deep wilderness. In search and rescue operations, a drone can execute a massive grid search over a dense forest, using predictive analysis to spot a missing person without a human pilot steering the search pattern. Over farmland, the system processes multispectral imagery on the fly. It counts individual plants, identifies pest infestations, and calculates the exact density of a crop in real time. Human intervention is being systematically removed from the loop as these machines learn to adapt to their environments mid-mission. The exact same computer vision models designed to find a cracked pipe can be trained to classify an adversary or target a vehicle. Because the AI is embedded directly on the aircraft, military drones can operate deep within denied environments, airspace where traditional communications and GPS signals are actively jammed. Equipped with sophisticated perception software, they can navigate complex terrain and execute lethal targeting decisions while completely cut off from a human command center. Solving the technical puzzle of flight autonomy was the first step. The second is weaponizing that autonomy, stripping human oversight out of combat. This assessment from the RAND Corporation outlines the logical conclusion of these advancements, warning that intelligent swarms are a severe and growing threat to homeland security. Using 5G and the Internet of Things, hundreds of independent units communicate and synchronize. They share sensor data in real time, responding to external stimuli as a single coordinated entity. The asymmetric risk is massive. Illicit actors can acquire low-cost commercial drones and deploy an intelligent swarm to overwhelm and destroy critical infrastructure, like electrical grids or power substations. While the individual drones are cheap and readily accessible, fielding the radar and countermeasures required to stop hundreds of small, evasive targets at once is financially devastating. We deliberately cut the leash to make our machines faster and more independent, but as they begin networking together, thinking and acting as a swarm, we have to ask ourselves who is really in control.